Good day, class. Today we're going to go over Unit 5, SAS 2, comparing linear and exponential functions. I find this unit interesting because now that we had some experience with linear and exponential functions, and now that we explored them using recursion and explicit function rules, we've come to have a better appreciation and idea of how these functions work and what makes them distinct. Now, what we're going to do in this lesson and what's going to be beneficial for you is to solidify this discovery of what makes them different. What makes an exponential, what makes a linear. And in order to do this, I want to go ahead and take you back to this example. I want you to recall when Cohen was selling magazines and his money that he was making from his magazine subscription. Take a moment to look at this table, and I want you to look at the data set. And I want you to look how it was produced, because what I'm going to do now is I'm going to go ahead and ask you a couple of questions in regards to this data set. Here's the two questions I want to ask you. What is the rate of change of the data represented in the table? And second question, how does the problem change if Cohen's earnings grow exponentially? What does this mean in the context of the situation? What I'm going to do now is I'm going to pause the video, and if you need a reference back to the table, just look at your paper. The same table is listed on number 1 of your paper. So what I want to do now is pause the video and call on somebody randomly to share their answer with the class. So I'll go ahead and pause the video now. I want you to look at this picture, and I want you to see the illustration of how you tell if something is an exponential function. Now, it's become clear that when you look at a linear, something was being added by a constant amount. Well, an exponential, it's the same idea, but instead of adding, we're multiplying. So if you look on the left where it says growth factor, you'll see that something's being multiplied by a constant amount. On the right, when you have a decay factor, it's the same idea, but now it says divided by 3, but really dividing by 3 is multiplying by a third. So it's the same thing, but now when you have a decay, it's just a number that is less than 1. It's a number that is a decimal. And that's how you go ahead and identify an exponential growth or decay by looking at data sets. Now, what I want us to do, class, is go ahead and finish our number 1, and I'll be picking up number 1 today. Number 2 of this packet, I'll be picking it up tomorrow. So let's go ahead and start working on that. If you have any questions, please see me in the back.